All right, geometry topic 6 review on quadrilaterals and their polygons. I really think the state test likes quadrilaterals even more than triangles. Okay, so the first thing is the polygon angle sum theorems. You might need to know this to solve a problem. This is much more of a middle school idea, actually. Okay, so remember that if you have a 5-sided figure, 180 times 5 minus 2, that's going to give you the sum of all the angles in the polygon. And then you have the polygon exterior angle theorem that says no matter what the shape is, the sum of the exterior angles is always 360. Okay, but again, I'm not sure if you'll see that on the state test. More of an ACT thing. Okay, then you have kites and trapezoids. Again, I don't think you'll see this. The area formula for a trapezoid is on the state test, but I really don't think you'll use it, to be honest. And now we get into the big guns, right? Parallelograms, right? So parallelograms is a huge topic on this state test. So first of all, remember that a parallelogram is a parallelogram because opposite sides are parallel. So in this picture, AD and CB are parallel, AB and CD are parallel, right? That's what makes a parallelogram a parallelogram. So now you have four other key pieces of information or characteristics you know. First of all, consecutive angles are supplementary. So that means the ones next to each other, like angle A and B. Angle A and B are going to be supplementary. It's because they are same side interior angles and you have parallel lines. Opposite angles are congruent. So now angles A and C are opposite. They're going to be congruent, okay, or equal in measure. Then over here, the opposite sides are congruent. So not only are they parallel, but they're also congruent, right? Two pairs of congruent sides. And then the diagonals bisect each other, right? So in this picture, so A to X is the same as C to X, and B to X is the same as D to X, which is down here, right? So properties that you need to remember. 6-4 is just the converses to 6-3. So again, I don't think you'll need to specifically know these, but there they are. All right, and then you have your special parallelograms, right? So now one of the things you'll see on the state test is, okay, so this is a parallelogram, right? So from a parallelogram, you have two breakoff points. First, you have what's called a rectangle. So a parallelogram has opposite sides parallel, yes? So a rectangle has 4 right angles. That's what makes a rectangle a rectangle. A rhombus has 4 congruent sides. So it doesn't have right angles, but it has 4 congruent sides, not 2 pairs of opposite sides, but all 4 sides congruent. And if you are both a rectangle and a rhombus, then you are what's called a square, right? Which has 4 right angles and 4 congruent sides. So this is called the hierarchy of parallelograms or quadrilaterals. You will definitely probably see this on the state test. Okay. So if a parallelogram is a rectangle, because it is straight up and down, the diagonals will be congruent. Okay, so this A to C is equal to B to D. So notice how they have them marked all congruent here. So these 4 pieces, because it is a parallelogram, so they are bisecting each other, and they're originally congruent, so all 4 pieces are congruent. For a rhombus, you have 2 facts about the diagonals. I think the one that's most important is the fact that they're perpendicular, right? So because you have all 4 sides congruent, right, you create 4 congruent triangles in this rhombus, and again, where these diagonals meet has to be a right angle for them all to be congruent. Okay, and then last but not least, if you have all of these properties, you are the square. So the square is what we call a regular quadrilateral. 4 congruent sides, 4 congruent angles. And then 6-6 is just the converses to 6-5. So again, if you know 6-5, you're in business. But again, parallelograms. You'll see proofs involving parallelograms that involve triangles, because if you have a parallelogram here, you simply draw one diagonal, now you have 2 triangles, and using congruent triangles is a great way to prove some of these parallelogram theorems. All right, and there's topic 6.